Hey guys, it's Reed here, and this is episode 32 of Contest Coding. Today's problem is called kitty fencing, and there are a couple ways you can probably solve this problem. The easiest one that I found is just using a switch case, because essentially there are three different cases that you have to account for. If the number of sides is 1, if the number of sides is even, and if the number of sides is 3. Because it's only going to be between 1 through 3 or 1 through 4 are the side links, so you really don't have to worry about that many cases. It makes it really easy just to use one switch case and solve it that way. So first, you're going to have to load in your variables. So I'm going to take the money variable, the unit price variable, send that next int really quick. And then I'm going to actually, before I do any more, I'm just going to derive the price that I'm using to calculate with, which will be equal to money divided by the unit price cast to a double, so I get my decimal answer. Then I'm also going to store the sides as just another integer. Okay, so once I have the sides stored, everything is good to go. Now I just write the switch case. So switch of sides, because that's what I'm using as my determining factor. I have a case where it is 2, a case where it is 4. So that's catching those. And inside the case 4, I'm going to take a double even cost, because this is going to be the even case. And I'm going to go price divided by double sides. So that's just going to how it's the math that you take the price, which is 5 divided by 1 divided by 4. So 5 divided by 4, 1.25, that's your side length, or your side value. Then I'm going to do a printf so I can match the formatting really efficiently. So I'm just going to go percent $1. So I'm going to store only with one even cost. So I'm just going to do $1 to take the first one twice. Dot to f x percent $1 dot to f yards, all caps, followed by a new line. Let's go back there, and then I'm going to have even cost inside the printf. And then I'm going to break so I don't do any of the other cases. Then I have case 3, which I'm going to solve with double case 3 as my variable. And case 3 is interesting, but it's really not that hard to worry about. You just have to think, okay, divide by 4.0 to make it so it has 4 sides. That's how much the cost would be if it was an actual square and you wanted all 4 sides. And then you're going to do out.printf %.2f, oops, there, %.2f x %.2f. So there are going to be two different variables here actually, and then yards. And my first one is going to be case 3 times 2, because you solve for 4 sides and you only have 3 sides, so the one side, the larger one, is going to be twice as long as the side that is normal in length. And then you'll break out of that case. Then you have case 1, which you're going to just solve with double case 1. And actually you don't have to do any double case 1 here. I'm just doing it to make it consistent all the way down my application. So in case I do have a mistake, it's easy to debug and I can have variables for the things I'm trying to fix. That's one thing I've picked up as I've continued to do a lot of coding, is that using lots of variables, even when you're just setting them equal to each other, is good because it makes it clear in your code, and you can debug it, and you can have your peers debug it for you and help you with it whenever you are going to make a mistake. So there's case 1 there, and I'll break. And I'll also include a default case just in case I have an error, and I'm not sure why there shouldn't be an error in it, but if I do have an error, I want it to pop up when I'm doing my first run, just so I don't have any issues in the long run. Okay, so that looks pretty good. Now let's compile fencing.java and let's run it. And we have 1.25, 1.25, 3.5, 1.75, 0.25, 0.25, 600, and unknown yards. There it is, perfectly correct. Thank you for watching, and I'll see you in the next episode.